It's nice to meet you all again virtually. It would have been very nice to have met physically, but this times again will not allow us to do it. So we'll be missing the actual energy. Yeah, but so we have understood that you have some difficulties and want some clarifications from Anes sir, and Anes sir has graciously accepted to solve the issues that we have. So I would request Anes sir to make a small presentation and then take your question, so that you have best of both. You would have the start point of certain exercise and then followed by your questions. Yeah, over to you, Anes sir.
Thank you, Sai sir. Hello, everyone. As Sai sir said, actually, समोरासमोर असल्यावर खूप बरे जाता असल्या गोष्टी. We'll try our best. I know this is going to be difficult. Coordination issues जाता, network issues असतात, and all that thing generally happens. We'll try our best to address your queries. But if something is left out, please do understand, and we do apologize for that. Once everything is probably back to normal, or at least good enough to be normal, we'll definitely meet face to face again, and we'll try to address much of this in more detail. But let's attempt to do something best of what we can do in the current situation. I know there could be many questions. We do have less time. So I will probably request everyone to start using the chat window as much as possible to drop your questions, or maybe coordinate directly with either Sai sir or maybe Pallavi ma'am, and then sort of she can sequence the requests, and she can sequence the queries and then send them over one by one, so we can address them without causing any conflicts. Is that good enough? Great. I assume that means yes. Yeah, so let's start. The session is already being recorded. So those who are missing out for any reason can always refer to the recording later. So who's going first? Pallavi ma'am, would you like to start?
Sir, so we joined early.
There are 51 right now.
Yeah. Okay. So 51, V12 and 51. Sir. Hello.
Yes, yeah.
Good evening, everyone. So, as we had conducted the handholding session, we came across certain queries, and this code can be done in this way, that way, and some teachers even directly called us, and why cannot we use the repeat loops and that. So I think it was, and after the gravity, means many sending the code actually. So that's why we all MPs, most of we coordinated with each other and demanded this doubt clearing session.
Good, ma'am. Yeah. So can we go through those doubts one by one, and we can start addressing those?
Yeah, sir, we have shared one link, okay, in Master Trainer group. Those who have any queries regarding any code and all, kindly take the screenshot of your code and paste it in that document, so that sir will be able to clear your doubts.
Since it's not there right now, it's empty. Who's going to ask the questions? Like, we can start with some questions, right away.
So most of the we wanted this explanation on Moonlander, sir.
Okay. So let's start with that. Let's start with the Moonlander. I'll not open that code. The entire idea, right, is there is actually more than one way of doing it, and we sort of need to accept it all. It's not like this is the code, just do that code itself. There are actually more than one ways. Obviously, there are constraints, which I think there are questions around why those constraints are there, and we'll talk about those. But following those, essentially, largely any aspect of the solution would be okay. So one solution, right, the way the landing occurs for anything, right, the way the plane lands or any landing that generally occurs is because of a gravity. So what do I mean by that is the planet or the body tries to pull another object towards itself. So like, for example, things fall down, right? And we need to simulate that. Landing is essentially falling down in a bit controlled way so you don't break, right? Otherwise, essentially any landing is basically falling down. So if, let's say, I have a piece of paper, if I just throw it, there is air, which is sort of holding it, right? So it sort of glides slowly down. But if I make a ball out of it, like, just crumble it together and throw it down, it will fall a bit faster. Not because gravity affects differently, but because of the air around it. Now, in case of moon, there is no air there. There is nothing, there is no concept of friction which will slow the landing down. So what that means is this object will continue to gain speed as it goes down because there is an acceleration. So gravity, whatever we say it, right, is in a perfect sense nothing but more than an acceleration. So you can, acceleration everyone understands, right? So if you're on a bike or a scooter, we pull the accelerator, it continues to change the speed. If you are pulling it, it will continue gaining the speed. That's exactly what the gravity is. So what gravity tries to do is it tries to give speed towards the ground for any object that is not on the ground. So everything sort of falls down. Now, what do you mean by velocity? So let's talk about that, right? So let's try and simulate this. So what I'll do is I'll share my screen. Okay. Let me know if you can see the screen. Can you see the screen?
Yes.
Right?
Yes, sir.
So just to give an effect, right? Let me sort of reduce the size of it. So there will be a more falling down effect here. So let's say it is at this point and it has to fall down here. Let's start with that basic rule, right? So it starts with here and can go all the way down till, let's say, this point. And that is minus 154. So it should not cross minus 154. If you see, we want it to stop here. It should not cross minus 154. So how do we do that? So ideally, we would say, let's start with this. There is no pen block here, so let's not talk about clearing any of those things. I want it to be literally placed anywhere, either here, here, here. But no matter what it does, its y should not cross minus 154. So what needs to happen, right? Let's first say that it has to always point in the direction 90, correct? Like this. And we have to continue changing its y value. We have to keep moving it down. That's the force, the side from which we will try and impact the gravity. And the idea is, no matter where we keep it, here, and always place down, it should fall down and stop at minus 154. So let's do this very simple effect, and let's call it fall down. Now let's create a block. And let's say fall down, right? Very, very simple idea, fall down. Now, what this fall down should do is, as long as the cat is not below 154, it should, let's say, come down by some value. So let's start that. It's recursion, right? So if you see from that point, it's recursion. And what's the condition here? the condition here is, we can say, as long as if y position, so that should be in a motion, if y position is less than, correct, actually, is it less than or greater than? Because negative goes like this, right? Keeps increasing like this. So if it's not actually less than, it's actually greater than. So operators, if y position is greater than minus 154, minus 154, right? If it is greater than minus 154, then we need to get it down. So how much should we get it down? Let us say, change y by, what should we say? Minus 1? Right? So it will come like 1 point down. Change y by minus 1. And we need to make one, we need to really make sure that, there is quite a possibility that while this is happening, it will actually go below 154. But if that happens, then we have to fix it at 154. So let's also do that. Let's put another if condition there. If operators, if the y position is less than minus 154, y position, where is the y position? If y position is less than minus 154, correct, then we have to set the y to minus 154. So it stops here. So it sort of like, comes back to this line. It will never go below this. And at the end of it, we need to say fall down, correct? So the fall down loop will just continue occurring. Right? So this will continue to happen. Now there is nothing in the else block, which is fine. We'll keep it for that. Otherwise we'll just change it to its normal if statement. And let us see what happens if we run this. So let's skip fall down here, and nothing happens. Because it's not up. So let's move it here. Let's do this. You see it is falling down. We'll stop here. So no matter where I place it, like this here, it falls down, correct? So we just did something that is falling down, but this is not gravity. This is maybe like, coming down, you can say, or, but this is not gravity because nothing is accelerating. So what is accelerating? So acceleration basically means, if you see, right, let's say fall down is called once, fall down is called the second time. What is the difference between y value? Always. Can somebody tell me?
Yeah, y value will be more. For example,
No,
first
what is the
time
difference? What is the difference between
double.
What is the difference? What is the difference in the value?
Here you mean to say, sir, or
In this example right now,
minus one.
minus one,
Minus one.
correct. So no matter what we do, right, it is always minus one. At each step, it is minus one. Correct. So keep this in mind. At each step, this is minus one. Now, what does this mean? Is this basically means it is coming down at a constant velocity. The change in the position is constant between, keep in mind the word, the change in the position, right, is constant between the two calls of fall down. It's always minus one. So its velocity is not changing. Gravity means acceleration. That means just like velocity is the change in the position, right? Acceleration is change in the velocity. So which means, let's say at the first attempt, it's coming down at minus one. In the next attempt, it should come down at, let's say, something like by minus 1.05. In the next attempt, it should be an additional point around that, which is -1 point, another 0.05, adding to that value. Right. So what happens is over the period, right, the change in the distance between each call keeps increasing. Does that make sense? Right now, the change in which it is coming down is always -1. If it keeps increasing by a given amount at all point of time, that's an acceleration. So that's the gravity. So we have to make sure that this value here always changes by some amount. How do we do that? Let's quickly make that change here. What we would do is, if we need to change it always, right? There is a common rule, right? We know that we have to pull this as an input up. So let's edit it and add an input and say change in position, you can say. Okay. And we always come down by the change in position. And for now, to keep it exactly same as what we are starting with, let's keep it -1. And the whole program behaves just like how it was behaving some time back. Take a look. Correct? Is everyone clear till this point?
Yes, sir.
Okay. What we now need to do is whatever that change is, right? Change in position, we have to increment it by certain amount. And that makes it a gravity. So if I say change in position now is operators, and I say plus change in position plus 0.05, 0.05. Okay. So add another 0.05 to it. So acceleration would be -0.05. And if I do this, take a look at how it falls. Did you see that? You can actually make it 0.1. You can see how it falls now. Is it good enough, everyone?
Yes, sir.
See, it behaves more like a gravity now, right? Try throwing something down from various heights, and you will see that the more the higher you throw it from, the faster it falls. See, so it gains speed. But no matter what you do, the gain in the speed will always be, the difference between the two speeds would always be -0.5. So our acceleration is -0.5 in this case. So that's something to sort of keep in mind. Right now, whenever it touches down, depending on how hard it hits, we can say that that was our velocity at that point in time. Okay. So let's try this in a way. So let's what will happen if we keep this running? If we keep this running, like for example, even if it is here, right? I need to say, keep this running till don't just stop. And there is a reason I'm doing it. So just bear with me. There is a reason I'm doing it. So don't just stop. And the reason I'm doing this, but let's first put that in place here, like this. Never stop. So this block will never stop. Come down like this, and it stops. So what I'm going to say is at this point in time, right? This change in position, I'll reset it to 0. This change in position, which is here, I'll set it to 0. Unlike doing this. So I'll say 0. So it will no longer fall down anymore. But it will continue running in the loop. Yeah. So it sets itself to 0. This is good enough. Now let's try to make it jump in the first case. Now, how do I say that it is jumping? I don't want, like, while you are in the air, right? You cannot jump. You can only jump when it is. Take a look at this. And like get it here, throw, and it always falls down. Right? So it starts from 0 point and it sort of accelerates as it is falling down. Now jumping, the moment you get the gravity right? Jumping is very easy. Jumping is nothing but one time push in some upward direction. Now, if downward is negative, what is up?
It's positive.
Correct. If down is negative, the up is positive, right? And here what we are calculating is this change in the position, right? Which is there, and always move it by that angle. That's what we are saying. So if the value is always facing, if the value is higher, so let's say when this happens, right? Let's say if I say 5, just take a look at what happens. So this code won't execute because this code is not doing anything, right? So over here. So while this will only work while this is less than code, and it is only trying to pull it down. But at this point, it is just asking it to do this. So we are now going to say an additional logic here. At this point, we'll also put an additional logic, right? That additional logic should be, this is fine if it is greater than this, but we would always say change y by change in position. This, no matter what happens, we would ask this to happen before, like this. Okay. Take a look. It's already jumping. Okay. So let's say this 0 and everything looks normal. Okay. I can get it here, it falls. I can get it here, it falls. I can, oops, it went down. It sort of went down because when it was less than this, oh, it still added this additional 0.5, right? So that sort of caused a confusion. So what we should have probably said is if this is less than minus 154, set y to minus 154, but don't again sort of change this. It sort of did this, right? So what I would do is I'll take this, I'll change this to if and else, because now there are two possibilities there. Here, if it is less than minus 154, then obviously set it to minus 154 and fall down by 0 value. Fall down by 0 value, else the earlier one. Now we are fine. Now it won't fall. So let's do this. Still there is a problem. Set y to minus 154 if this is greater than minus 154. Change y by this if the position, oh, okay. So this change should actually then come up. This is fine. We'll just do that change above. Where is the control? If, yeah. Again, I'll possibly require another if else. If y position is less than minus 154, because I'm doing the change here, right? If it is this, then set it to minus 154 and always say that this is the case, else handle this case. So this looks good enough now. If y position is greater than 154, this is not required. Always fall down by the change in the velocity. Yeah. There. Right? So we just got our code, which does this. Let's make it jump. How do we make it jump? Can somebody tell me how do we make it jump now?
We have to give positive value if it is
Right.
coming down.
So the value
Press.
now, if is, so the value
Press.
now, if is, we have to just make sure that if there is a key press, and that should happen when only when it is not on the ground, right? That is around this situation. If there is a key press, essentially in this condition now, in the else part, if there is a key press and if I press the up key, then just give a change in position to some positive value. And that's it. It will work. So before we call this fall down, let's put one more if condition here. Obviously, this needs to come down. And we would now say if sensing, we need a sensor, right? If, where is the keyboard? If key, space, or let's say up arrow is pressed, obviously, okay, sorry. The problem with this is it will go in a wrong kind of recursion. Again, this needs to be if else. If else, and in the else it will be fall down. If the up arrow is pressed, it should be fall down with some positive value. Let me say 2. Now give it a try. So if I press up, see, it jumps, but very low value. So let me just say something like 100, right? Oops, too high jump. So 10, I think. First, let him fall down. Yeah, there you go. See, it's jumping now. Good enough? Can everyone see what's happening here? And if I move it up, so it's actually behaving like I just build a gravity. No matter what I do, I pull it up and then falls down. And then there is a jump. So I'll now rename this to gravity. Oops, not here.
So,
This is
yeah.
yeah.
Hello, sir.
Yes, ma'am.
So we had a question from teachers in handholding session, like why we have to make it plus only
Where
for
plus?
change in position plus minus 0.5. Why it cannot be minus operator and a plus value?
So see, you're describing the force here, right? It can be, but the messaging is wrong. The messaging here is you are always adding the forces, or you are always adding the acceleration. You're not subtracting the acceleration. Keep in mind, like, it is not slowing down. It's speeding up. So what is the sign, or what does speeding up means? Adding or removing?
Adding.
Adding, right? So that's what this is, adding. And why is this negative? Is because we are trying to keep it constant. This is a negative acceleration. Positive acceleration is going up. Negative acceleration is coming down. And because of this, right, because this is plus and this is minus here, you can get this jump effect with just one line change. You are saying jumping is nothing but it's still an acceleration, but in the positive side. Falling down is an acceleration, but on the negative side. So this is what it is. Does that answer the question?
Yes, sir.
So this is essentially the idea. You are always adding the forces. Nothing changes. In the universe, you are always adding the forces. Whatever the forces are, whether it is going plus and then it is taking the negative side, it's all finally the addition. Negatives, essentially, whenever we talk about subtraction, right, it's never a subtraction. It's always an addition. And that's why we have negative numbers. So 2 minus 2 is nothing but saying go in the 2 direction first, 2 is positive, right? So go towards the right side first. And 2 plus 2 basically means go in the right side first, then go another 2 steps in the right side. So you reach on the point 4, right? 2 minus 2 essentially is go on the right side by 2 steps and then go, not like go in the past. If you say negative, it's like, if you say subtraction, it's like going in the past, but you cannot go in the past. Let's say you still go, but go on the other side. So you say go on the right side 2 steps, go on the, you say, don't say come, go on the left side 2 steps and you reach back where you had started. So that's 0. Correct? So that's what it is. When you say 2 minus 2 is actually 2 plus minus 2. So this is actually a good thing while teaching the students also, because subtraction is not exactly removing. If we start teaching that subtraction means removing, that is the reason why students get confused a lot with the negative numbers. How do you remove something out of 0? How can you tomorrow say 0 minus 1? That is not possible, right? It should not be calculatable. It should be something like division by 0, not calculatable. Division by 0 is calculatable, but removing something from 1, how is it? It is calculatable. That's confusing, right? That doesn't work, right? You are not removing, you are just going in the other direction. It's still addition. You are still adding it, just in the different direction. And this is very much clear in the financial accounting. Anybody from BCom side, right? There is nothing like debits. You always add it somewhere. It's called double book accounting, right? If you are saying credit or debit, both are essentially same. It's just that which book you are adding that makes a difference. But the total always comes the same. Yeah, so that's the idea behind it. So this is our gravity. If we need to make it a moon lander, so keep in mind, right? On moon, there is no atmosphere. Hello?
Sir,
Yeah.
hello. Yes. In the first if condition, instead of taking y position less than minus 154, we cannot use equal to sign, because at a certain point it will be minus 154.
Need not be. Like, for example, here you are always increasing the value, right? You are adding some value. If this was, let's say, always minus 1, then yes, it would have reached minus 154 some point in time. But let's say if this has reached the position, let's say here, minus 153, and the change is by minus 5 now, because you are adding it, right, always. So it will actually reach something like here, minus 170, and the equality won't hold. So we are saying equal to is the position where there should not be any operations. You should do something when it is either minus 1 less than that, or when it is greater than that. Equality is 1 when everything stops. So that's why it's not on equality. In the earlier case, right, where we had this always reduced by minus 1, equality would have just worked fine. No, not in this case. You can actually do that when you are conducting the sessions, right? You can actually start with minus 1. You can make it equal to minus 154, and you can say that it stops. But the moment you start making these other changes, right, just like how I went step by step, you will see that it actually go below like this. And that's because it will skip that increased value. It will skip that 154. It will, at one point, it will be less than 154. And suddenly at one point, it will be greater. Sorry, at one point, it will be greater than minus 154. And at the other point, it will suddenly be less than minus 154. So that will break. It's basically try and error in front of you, right? It's not I come with the code in the mind. It's like I see a condition, I fix it. But the idea is simple. It should always change the y position, the change by y position, this value. Always take the last value of what its change was, add a constant value to it. Again, what was that total change in the last step? add that same constant value to it. That's exactly what we are doing here. Makes sense, right? Now let us do moon landing. So let's say this is our rocket. A very bad looking rocket, but let's consider this is our rocket. So how would a moon lander work? There is no atmosphere, right? So what it tries to do is it tries to use rockets. And what is rocket? Rocket is exactly like jumping. Whenever rocket engines are fired, it gives a force in the positive side. And force is also an acceleration. If this is how you need to talk to the students, even if they have not learned things, right? Everything is an acceleration. If you have been watching the sessions which Manish Jain was conducting, he says generally we confuse by adding more terms. Like for example, we say this is an accelerator and we call brake. Brake is also an accelerator. Brake is an accelerator in the reverse direction. The one what we call as an accelerator is an accelerator in the positive direction. Because if you see, when you press a brake, the vehicle just doesn't stop. It slows down, and then it stops. That's a negative acceleration. If when you accelerate again, it just doesn't reach the speed of, let's say, 20 kilometers per hour. It will slowly start from 1, then it will go to 5, then it will go to 10, and then it will go to 20. So it's accelerating. Both are accelerators. So gravity gives a acceleration in the negative side. The rocket engine gives an acceleration in the positive side. But unlike jump, which, like for example, if I press the button and hold it, you don't just jump in the air again while you are in the air. The jumping again will happen only when you have touched the ground. Unlike that, rocket engines actually give a force while you are in the air. So you can do that. So this condition of key -1, right? We need to change it. This is not happening when it is always slowing down. It needs to happen always, even if you are in the air. No matter what you do while you are pressing that value, it will continue to add this positive acceleration from that point in time. This is what rocket engines do. Eventually, this value adds up to so much that it actually breaks the negative acceleration and it starts going up. Right? Have you seen the video of how SpaceX rocket lands? If not, maybe I can later on share it. So they're actually using rocket engines. So when things fall down, at one point they start the engines, it comes down. Now, landing basically means when it is having a negative acceleration here. Take a look at this. There is a negative acceleration there, which basically means, let me say this, that when it is when it is 154 right here, when it is trying to stop it, let me say its value. Let me say the value of minus acceleration. Okay, let me say what is the acceleration that is in looks, right? So say for 2 seconds, and I'll give the change in position here. So take a look what happens. Okay, let's start this. It says -1. Okay, -17, right? -17. What about here? -8.50. What about from here? -5. -16.50. See? Landing basically means when he touches down, the acceleration needs to be close to 0. Close to 0. It cannot be like just 0. It will just float otherwise. So when it is coming down, it has to be close to 0. So something like say -1. -1 is very safe. So -2.50. Right? Yeah. So -9. So maybe something like, yeah. So it should be greater than, we can say, -2. And if the acceleration is greater than -2, we can say it has landed safely. should be either 0 or greater than -2. And so we can calculate that value. So how do we do that? Is we say we'll fire the rocket, right? And when the rocket is being fired, it will try to continuously add some additional value, right, to this change in position. So that's what we now need to do. So let's quickly do this. How we are going to work it out? This is fine. If the position is this and all of that is just fine. This part is okay. We just need one more additional if here. And that should always work. And we should say here, if sensing, where is that operators, right? I think do it first, maybe here. I can do it here. Right. So I'll say if I have rocket engines being fired, where am I? Oh no, I still need to get my change in position. So let this change occur. And once this change occurs, and if I have my engines being fired at this point in time, where should I say it should be? While it is greater than -154. Yes, it has to be while it is greater than -154. Here I'll put a check. One more check. Right? And I will say, take a look at this, okay? Operators or if condition, right? I need one more if else here. So if else, I need to see whether my key is pressed, and that would be sensing. When space key is pressed, I'm now using a different key here. Or when it is not pressed, this is the logic. But when it is pressed, what should I do? So this will always occur. The negative acceleration would always occur, right? It's just that if, let's say, I'm firing an engine, then I need to continuously add some positive acceleration also to it, right? And it is going to fly only when this positive acceleration is going to be so much that eventually it will just break, it will just cancel this continuous -5, which is occurring. So how should we do that now? So let us say, I will, if this is -0.5, right? I'll say positive acceleration should be 0.6. Remember that to fly, it has to always break, or its positive force should be greater than the negative. So gravity, I'll copy this internal block actually here, but I need additional plus force to it. That is, it will go like this. And this I'll say 0.6, right? So possibly this should work. It's -5 if I press this. So this is not working because it is always on the ground now. So let me first jump. See, it's going up. So I'll actually make this 0.6, maybe 0.7, or maybe 0.8. So run. Yeah, it's going up. See, it's sort of, see, you can now say there is a rocket. So if it lands, and while it is landing, if it's, yeah, see, -2.0, then I can say it is succeeded. So when it is landing, that is in the else part, if my acceleration at that point in time here, I can say, okay, when it has landed, that is when it has actually gone -154, or I can even check that if the velocity is 154, equal to 154, If that happens, then I can sort of stop it. Or it could be this case. Most probably it is going to be this case. And in this possible case, if my acceleration or change in position is greater than -2, else I'll say I lost. So let's just put the condition here. What do I need to add? Operators, control, if and else. This isn't very friendly. Let me just take this whole block out and split them apart. I'll build something and then I'll move this. So I need if and else. And at that point of time, I'll say if, so I need an operator. If my change in position while it is landing, like while it has landed and when it is stopping completely, is greater than -2, then I would say, obviously, this has to be the case first. Then I'll say not hello, but landed successfully, right? Else I'll say motion, no, not motion, looks, right? Say for 2 seconds. Correct. Then I'll move this whole block here where I was there. So right now it's saying landed successfully. So let's always start from some top point. It's okay, crashed. Okay. Crashed. You have to time it in such a way that it really comes down slowly. Crashed. It's really difficult to always get it above crashed. Let me play a bit of cheat here. Maybe I'll just say -3. Yeah, landed successful. Right. I can actually go and change this part a bit. Right. I have this. I'll remove this part. I'll duplicate this. Right. And I'll say at this point in time, just as an after effect, right? I'll name this one as rockets, and I'll possibly try and throw a flame below. Like this. So I can change the costume. So yeah, going back, that is here, right? If else, if the space is pressed, I'll change the costume looks to say switch costume to rockets, else switch costume to costume. And remember, I just changed something about things, right? So by clean slate, switch costume to costume. And yes, now we can always place him at some given value. So we can always say set the y to maybe 152. So at starting, set y to 152. So it will always start from this point, and let's now try doing it. Ended successfully. Right? Everyone saw what we did here? Hello?
Yes, sir.
Take a look at this. Do not directly look at the code, because this whole big code, right, did happen in one go. We first did something falling down, then we added a downward acceleration to it. Then we made it jump by adding an upward acceleration, right? And then we finally just changed to a rocket engines being a jump, but that can happen while things are falling down also, right? So this code and this code here is almost similar, right? But this happens while it is falling down. This does not happen while this happens only when it is like jump happens only when it is on the ground. That's it. Now just change the costume, put a nice background of stars and a moon. And if you can change the value of this minus 154 to whatever is the ground level of the moon, this is done. That's the moon lander. So I can actually save this to the computer right now. And don't worry, right? Probably if you look at this, right, this code, it will look completely different from what is probably there earlier. Probably if you ask me to do this again 3 days later, it will again be completely different. Any questions?
Thank you, sir.
Questions are come up in the document.
So I am just saying it. Can you share the code with me, ma'am, around this? So I'll explain it.
Pallavi ma'am, do you have the code?
Yeah. They have been shared with us.
Yeah, so would you like to present your screen and show?
No, I'll share.
Okay.
You can share it on WhatsApp with me and
So meanwhile, you could take up the next question, which is there
question.
regarding loops and recursion.
There's one more before that. I'll take that first. Now we observe that students are sending projects using variables. How can we guide our students to create projects without variables? Good question. Do not really discourage them from saying like, don't write it like this. Because first we need to get them motivated. First, they need to see that they can do it. So whatever easy things they could write, let them do it first. This is more thing, like we are not banning variables. We are just saying there is a better way of doing this. Then start with this, but move towards that. So accept it. Now give them a challenge. Can they do it without variables? Can we do it without setting anything? Right? Make them try this out. Give them as a challenge. Let them do it one by one. But everybody will do it at different levels, right? Because Scratch makes it easy to use variables. That's why people tend to use variables. If there was any other language which was not making it easy to use variables, they would have easily done it without using variables. But we really want them to come towards that side, and I'll talk about that's actually the next question. Why emphasizing on block approach, recursions, and no loops? Okay. Here's a question for everyone. So let me show you something. Okay. Not okay. A while ago, right, around 2 decades back, when we used to go to the shop and ask for a toothpaste, what did we used to say?
Colgate.
Yeah.
Colgate. So even if you wanted to buy Vico, right, we used to say Vico chi Colgate dire. If you see, Colgate is not toothpaste. Colgate is the name of the company, just like Vico is name of a company or Dabur is name of company. Right. Similarly for chocolate, what we used to say?
Cadbury di.
Cadbury di. Eclair की Cadbury थी. Right? These are synonyms. So when that is the only thing we see, right, it becomes a synonym. That is not the real name of it. And there are many such examples, like it's like Videocon used to be the name for TVs. No matter what to say, like Videocon, but we never really meant to give me a Videocon. Like, I just wanted to buy a TV. So this is how things generally shape up. Jeep, for example, a perfect example, right? Jeep. We still say Jeep. How many of you know Jeep was actually a brand? It's actually a company. It is not a type of a vehicle. It's a company. Right? The correct type is, I think, something like maybe 4x4s or SUV, as we now call it, right? Jeep is actually a company. So it became so synonymous with something. So these are all to do with synonyms. So when we let repeat like loops and everything, right? Let me say something, right? That's a synonym. And those things exist only in a type of programming language called as structured programming languages. Those loop blocks that you generally see, right? Like while, repeat, forever, and all that stuff. Those exist only in a particular type or particular category of languages called as structured programming languages. The only thing is, now in the current academics, when things are being taught, it includes all these sections, that there is something called as imperative programming languages, then there's something called as structured programming languages, then there is assemblers, there's machine language, there are functional programming languages, there are what you call as logic-based programming languages, there are mathematics-based programming languages. And we give a theory around that, and we do only structured programming. Because of this, what happens is, the side effect of that is, once programming goes to our head, right, that this is what it is, whenever we see any other type of programming languages, we say, where are these loops, where are these variables, where are this, where is that, right? And that's not what we are going for, right? Would you go for buying an electric car tomorrow and open up the engine and say, where is the 4-stroke engine? A car is essentially one that allows you to go on the road and go left, right, and all those things. So as long as you can do left, right, accelerate and brake, and sit comfortably, play this audio and like play the music and all that thing, that is fine, right? You don't say, okay, like, why aren't we putting a 4-stroke engine here? That happens because this idea of internals, of structured programming is so it has gone in our mind so much that we really struggle when we try to do something else. Like, for example, when people tend to go further and try to study databases, they have something called as a structured query language. SQL, it's called as. And people struggle because there are no loops there. There are no variables there, and they just can't code anymore. It is not that they can't code. It's that this programming has gone so much in their mind, and they see variables. There has to be a variable, they say. There has to be a repeat things, or forever, or for loops, while loops. Otherwise, I don't know how to code this. And enough of theory. Let me show you something. Like, just to give an idea, right? It used to be a part of the curriculums. If you are really looking at old computer science books or something, these languages used to be a part of the curriculum. It's just that now it has sort of taken a back step. But it is not. So let me share my screen. A perfect example, right? There used to be this language called as Prolog. So let me just show something. Okay. And this falls in a category called as logical programming languages. Now we generally say we need to teach most of these courses, right? They say we need to teach programming to kids because we want to, because they need to be good at logic. It's not true. you tend to be good with logic only when you use logic in your programming, otherwise not. Otherwise they are like, we never said like, I'm going to cook and I'm going to be good in logic, but I'm still following sequence of steps. That does not make me good at logic. You need to use logic to be good in logic. So let me show you something, right? And take a look at this. Okay, I'm going to do something and I'm not going to use loops or like, variables in the common sense, because you'll just see what I'm going to do now. And the way you program in Prolog, and you can literally do anything in Prolog, but the way you do it is you do not define steps. You define what your problem is. So what I want to do now is I want to build a program that is going to give me a list of 3 numbers. And those 3 numbers should be between 1 to 9. All right. Now, possibly if I say, like, calculate this, you would generally assume that, this would involve a lot of if statements, for loops and everything. But let me just do that without using any of those. And you'll be surprised how it works. But this is actually a programming language. Right now, in many computer science courses, this is there only in theory, but you're going to see it now. Right? So let me say the number, I'm defining facts now. I'm describing my problem is 0. Right? The number is either 0 or 1. And similarly, I'll continue defining it. It is either 2, it's 3, it's 4, it's 5. Sorry, I didn't define 5, right? Correct me if I'm wrong if I missed something. Okay. 7, it's 8, it's 9, correct? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my logical fact. My number, when I say number, it's going to be from 0 to 9. And now I need to define what a sum total of 3 numbers is. But I'm not going to say steps. I'm not going to say these are my steps. See what I'm going to do. Okay, I'm going to say sum of 3. And my 3 numbers are X, Y, and Z. Okay. And then there is going to be total. What I'm going to say, I'm describing my problem. What is my problem? That I have X, I have Y, and Z, which are numbers. So I'm defining my question actually. Just I'm writing my question. I'm not writing my answer. Take a look at that. I'm writing my question. My question is, I have X, Y, and Z as numbers. So I'm going to say the number X and, and or are the logical operators, right? And the number Y and the number Z. And, okay, total is X plus Y plus Z. Done. That's it. Anybody notices any loops here? Variables? Let us try and use this and let us see what happens. Okay. So let us say if I say sum of 3 and give me 3 numbers now between 0 to 9. Okay.
5,
5, comma
8,
8, comma
3.
3. Okay. And I say total. And now it's going to give me total. What is that? Existence error. Did I miss
Some
something?
spelling.
Yeah. So it's telling me like, there is an existence error there. So yeah, total is 16. Is that right?
Yeah.
Okay. But that's not what this is about. This is the best part about it. Now here is what I want to do. I have written this, like, it just calculated that for me and I didn't actually write the steps. You may say, okay, fine, this is like, but this is not what it is. I have actually defined a problem. Let me prove that. I'm going to turn my question now. I have defined my problem. I have defined what my world is. I'm going to turn the question. I'm going to say give me X, Y, and Z, which will give me total as 16. And now, if you are doing C programming, if you are doing Java programming, if you are doing any other type of structured programming, right? You will have to go back and write another code to do that. And what I'm going to do is I'm not going to write another code, but I'm going to ask computer to do the job for me and see what I'm going to now do. I'm now going to say, give me X, give me Y, and give me Z that totals to 16. And let's see how many other values we get. So it says 0, 7, and 9. Is that right?
Yes.
And that's not all. It goes further. 0, 8, and 8. 0, 9, and 7. 1, 6, and 9. 1, 7, and 8. 1, 8, and 7. 1, 9, and 6. 2, 6, 8. You see what just happened? I didn't have to go back. Did I use loops? Did I use variables? I wrote one code that does two things for me. And this goes even interesting. Like, let me just stop this, right? And let me say, fine, give me 16, but one of the number has to be 5. Is that possible? Yeah. The other two numbers are 2 and 9, 3 and 8, 4 and 7, 6 and 5, 5 and 6, 7 and 4. See? One code that solves 3 cases for me. No loops, no variables, nothing. Variables, loops, they are not programming. Just like Colgate is not about toothpaste. Colgate is a company, forever, repeat, if, else, all that is only in structured programming. But the programming itself, the world of programming, world where you do anything with computers, involves logical, functional, then what we call as mathematical, all those other, or assembly, for example, all those other kind of programming, where there are no loops, where there are no variables, where there are no, what you call as conditionals. Those things exist. Sometimes those things make simpler. You see, one code. This is actually what computers are about, right? Computers are not supposed to, they are not there to make you do a lot of things for where you need to do a lot of things. Otherwise, what is the whole use of computers? Computers is about helping you out. So computer should be, okay, tell me what you want, I'll give it to you. But when we teach computers, the way we teach it, right, is like computers is a dumb machine. You need to tell computers what to do. That is the reason. So if you see what we are trying to do, right, we are trying to build up what we call, even though the scheme has coding in the name, right? If you read the syllabus document, it says this is not about coding. This is about computational thinking, and this is about logical thinking. And to a great extent, not about mathematics, but it is about mathematical thinking. And we need to get these aspects in the course. We are not trying to make them programmers. Obviously, if they need to be good in programming, I mean, if they want to make their careers in programming, that is the time they'll have to learn C, or maybe C-like languages and other things. But what we are teaching them is about computational thinking, logical thinking, design thinking, and mathematical thinking. We are not teaching them programming. We are not teaching them coding. We are building up to it, starting with something they know, and slowly taking them to the next steps to really see the essence of what this is about. Not to treat computers like dumb machines, but to actually make them do things that will automate your solutions for them. So it's a stepwise process. This was not shown before, but I thought like this is a good time to do that. Does that answer the query, ma'am?
Yes.
Right.
So,
Yeah.
like, if this student sends a project, a certain project with the variable, so
Yeah.
like, how to remove that variable?
It's basically a simple way actually. All you need to do is in the block, right? Just accept that as a parameter,
Okay.
right? That's pretty simple. And when you want to change it, just call the block again with a different value. That's what we just did, right? Like for example, we add this y position, right? Change in the position. What we did with that, instead of creating a variable, we defined a block input. And we were reading from there. And whenever we wanted to change it, we were calling the same block again with a different value. So I just received this random bubbles. Let me share my screen again. Okay. Yeah. Can you see it? Is the
Yes.
screen visible? Okay. So yes. So can we repeat the question around this? You can go back and see the document, and the document says. So what's the question? If according to the expected outcome, randomly start and grow is the final block, then why is it not called under flag? Okay. Can everyone see the screen? If you trace it, right, it is actually called under the flag. See how it goes. Like, when you click a flag, it says create a clone of myself, comes here, it says do all this, and then calls it. So it's in the same path. Right. So maybe we can say the other way to maybe but the question has a sense, like it suddenly becomes confusing, right? So, and why it became confusing, because you see
So
that
I will send you a project which I have done, means maybe a Sandra teacher has done it in different way, Nazia teacher has done it in different way, even City Tejasvi has done it in different way. So sir, I'll send you my this.
sure, send it over.
Yeah.
What I'll do is I'll just meanwhile I'll just make a small change here, and I'll say create a block and call it for random what bubbles. So create for random bubbles, and this is what it is. So
So
yeah.
I have done it using only one create clone of myself. But
So did you send it, ma'am? Okay.
yes, sir, it's in the group.
Let me load it. Load from the computer. So let me share the screen again. Let me know if you can see it. Yeah, can you see it?
No.
Is the screen now visible?
No.
No?
It was visible sometime. Yeah, it is visible now.
Okay, great. So what this is doing is while it is at here, it says randomly start and grow. And then you say go to random position, create a clone of myself and do this. And when you start as a clone, you say show, wait, and then pick random 1, 2, okay, wait for that much time and randomly start and grow. This is also fine, ma'am. There's no problem here.
Okay, sir.
This is fine. You see, this is what it is about. Like, do not say that there is one true version of the code. So that's why the whole storyline does not really talk about the code. The whole storyline talks about the problem. Just
So
like,
I need to take the grow value as 0, then the down, it can be step +1 also. Like we need to tell our students, like if the input is changed, then you have to handle it. Like You can.
Yeah,
Like,
they
sir,
can.
yeah.
The whole lesson plan is only about creating some random bubbles. There is one more thing though to keep in mind. This could also be done by keeping multiple sprites. I can do bubble, 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 bubble instead of those 4 bubbles, and then that can also happen. What is not there in their course right now is the multiple sprite thing. So they can keep multiple sprites. Scratch allows that, but we have not yet kept that in Scratch, basically because Scratch does not support a very good inter-process or inter-sprite communication or messaging. You can send some very simple messages like I did this or I did that or this happened or do that kind of stuff, but you cannot specify a custom value in it. Like I am at position and this is the value. And what that does is, because of this language limitation, you need to sometimes break the messaging and then create something like global variables and then set the global variable and send a message. So for the same reason, in case of Scratch, and because we are not teaching them Scratch, we are slowly getting them towards idea of computational thinking. And we don't want them to actually go and start picking wrong concepts in terms of computational thinking. We are not going for multiple sprite options as part of this. If they want to build a game, great. That involves multiple sprites, great. Please do not discourage them, but do not actively teach it also. Hello.
Hello, sir.
Yeah.
There's another question, like why are we emphasizing on block approach, recursions, and no loops?
I just answered that one.
So for this, I had set an example for Salsit because I used to receive from my students also. I used to receive projects using Forever, because now they are starting to search for the Scratch programs over net.
Yes.
So even the teachers used to send the projects. So I had set an example for this using a windmill program.
Correct.
Okay. I'll be sharing it it on Master Trainer group. I would like to hear from Salset team, Sir Ashley, because he had sent. Sir Ashley, are you there? Hello, sir.
I think Sir is on mute.
Sir, I'm Sir Damodar. I have a question for you, sir.
Yes, sir.
Sir, it's about I've seen in different codes we've been using size and step, two, 3 blocks, and sometimes I feel it can be confusing for students if we use a similar or a same parameter, that we passed. We've been using that step and size for most of the blocks. So why it is so, sir?
So you generally don't need to use 2, but let us say 2 things, right? One simple example is generally you need a step counter to repeat something that many times, correct? So let's say you want to repeat something 100 times, you need to use a step counter that reduces down to 0. So you will say initial step is like 100. And then when you will call that block again, you will say -1. And the if condition over there would be, if the step is equal to 0, don't do anything, correct? So this is fine.
Yes.
This is completely fine. But here the value is reducing, that step value is reducing. Okay. Let us say we want to do something that the size of the shape should come down, as you go along. Then we can very well reuse the same step value as the size value also. But let us say the problem statement is the object should grow, from 0 to 100 as you move along. Now the question is, should you use the same step value or should you pass a different value? It could be done both ways. One way is do not introduce any other size value, but say at every step, the size that you want is 100 minus step. So when the step is 100, the size would be 0. When the step is 99, the size will be 1, and so on. So the size will increase. This is fine. Or the other approach is take the step size as a separate parameter. So your step would be 100 because you want to repeat it 100 times. Your size would be initially 0. And then when you're calling the block again, you are reducing the step and you are increasing the size. Both approaches are completely fine.
So what sir meant to say, no, like in one block, if I use a step parameter for the this recursion to happen, in the second block, can I use count?
Some
Because
other block, not count, but some other value. We've been using step for for different blocks. If there are 3 blocks, and let's say 3 blocks has to do some repetition of recursion of blocks.
That way. Yes, yes. You
But
can use
yeah,
anything. You can say step, you can use say count, you can say index, you can say current position. The perfect example, what we just did, right? We called it current position, correct?
yes,
Oh, sorry, change in position. We called it change in position.
yes, sir.
Could be anything. Just make it
Yeah.
descriptive.
Yes. Thank you, sir.
Thank you, sir. You shared your code, ma'am. You're saying something.
yeah, teacher Anupama, are you there? Hello.
Sir, there is one more thing I have to ask you, sir. Now I have noticed that even while passing the parameters to the block, I have seen we've been using like a way or a order to give it. Sir, is it required to have some order to start with that? Let's say first it is angle, then the radius.
No. That order is not important.
Yeah. Thank you,
I
sir.
can say radius and angle. Anyway,
Yeah. But,
order is not important.
yeah. Thank you, sir. Yeah.
Welcome, sir. Go ahead, ma'am.
Yeah, teacher Anupama, are you there?
Yes,
Teacher
Sonali.
Yeah, teacher Sonali Govekar or teacher Anupama. The example which was sent in Salsaid group for repeat and this to observe the block method and the repeat. So which was easy to understand.
Sir, sometimes when we want the result or the recursion to happen quickly, we want to see the result very quickly. That's where sometimes we use that forever or a repeat to test the blocks. But I completely agree with you, sir, that we should not be we should be avoiding those blocks, uh, and we should not be using it. But sometimes, sir, when we try different things and if we are curious that we want to result very quickly, that's where sometimes we use those repeat 5 times, like, just to check how the execution is, whether it is falling proper or not. That is the thing.
So which is completely fine. So as I said, right, if you are in an environment called a Scratch, and Scratch basically mimics a structured programming approach, right? So if there is a the whole programming language itself is designed in such a way that it makes it easy to use forever and repeat. Now what we are trying to do, right, is we are trying to focus on computational skills and mathematical skills and logical skills, design skills, and all those aspects, right? So what we want students to really try and put their effort into is fine, enjoy Scratch, But remember that Scratch is not going to stay with you. You have to see more things. And when we would do those other things, when we will start dealing with data, when we will start building complex games, when we will start building things like user interface and all the stuff, or even like a lot of complex interactions between many things, repeat forever for a while, all those things will only add to a problem, and you'll need a better solutions over there. So it's more like a practice thing. It is slight inconvenience. I completely agree. Like for
आवाज है ना सर?
Yeah, we can't hear you, sir.
Connection भी lost है.
Hello. No sound.
sorry, am I audible?
Yes, sir.
Yes, sir.
Current in between. Yeah, so we are just saying that when it is slight inconvenience, but while doing this, while enjoying what is there in Scratch, do prepare for things that are going to come in future. And those things, since we will move towards more computational thinking, more logical thinking and all that stuff, will actually start becoming easier more you try and do things without variables, without loops, and without conditionals. Does that answer your question, sir?
Yes, sir. Thank you. Thank you very much.
Thank you, sir. So just one, so that the message goes clearly, right? We are not trying to ban conditionals, loops, variables, or any of those things, right? Unlike many other courses, right? What this course is explicitly making it clear right from the start is variables, loops, and conditionals are not about programming. They are a part of a special type of programming called as structured programming. Just like petrol engine is part of a special type of vehicle called as petrol cars. Diesel engine. Some cars may run on hydrogen and they will have a completely different engine altogether. Electric cars have a completely different type of an engine, right? Now, why do electric cars do not have gear, for example? They don't have gear, right? But you can get your traction control, you can get your control of power and everything completely fine. That is because if you see, sometimes some things exist because of limitation of something else. Gears or transmission systems in petrol or these normal vehicles exist because engine has to keep running in a given speed. If it falls below that, then the vehicle is just going to stop. So there is a minimum speed limit on an internal combustion engines, right? That is why we have transmission control. So if you want to go below that speed, right? Sometimes we want to drive at a very slow speed, but we don't want engine to stop continuously. That's why we have transmission systems. In electric vehicles, it's motor, right? And one thing about motor is you get instant thrust. So you can just start the vehicle and at any speed, and doesn't matter. I can go very slow, I can go very fast, doesn't matter. So you do not have the transmission control there. Exactly like that. Things like Prolog, things like Lisp, which are there actually in some of the computer science curriculum. It's just that we don't we essentially only focus a lot on only structured programming languages. And that's why we see if else forever and all those things popping up every now and then. But keep in mind, if student asks you anything, if any parent says something, just let them know that this is a construct of only a structured programming language. It's like a difference between a Colgate and a toothpaste, or Cadbury and a chocolate. Right? There are many other chocolates available which are not Cadbury's. There are many other programming types which does not involve if, else, forever, while, repeat, variables, etc. All right, teachers.
Yeah, sir, I have one request made by teachers only, and we also. Now, since we Salset team is there in videography, we have received some SB3 files right from lesson 1 of Scratch to Moonlander. Okay, and when we go through those
Yes.
SB3 files, sir, they are completely different from day 1, day 2, day 3 video method. Means we had undergone training. Now these SB3 files on which the PDF is made, the teacher's book, should be sent to the teachers all over Goa.
So
Uniformity
again,
is
right, keep in mind the side effect of that. We want to make it explicitly clear is there is not just one way of coding it, or there is no right code. Sending the code and saying this is what the code meant has an implication that this is what the child should exactly write it as.
सर अनिल सर म्हणजे
Yes, ma'am.
या सो म्हाका हाजे रिलेटेड त्या खातीर उलोवपाक जाय आशिल्लें आतां पल्लवीन टॉपिक काडलो म्हणून आतां आमकां जे पळय व्हिडिओ करपाक लायल्यात ते आमी व्हिडिओ जर आमी कोड एक्सप्लेन करना जाल्यार व्हिडिओ कितें करपाचे सर ते ना जाल्यार व्हिडिओ नाकात
ना कोड एक्सप्लेन करपाक जाय पूण जे लेसन प्लॅनाचे जे व्हिडिओज आसात न्ही ताजो मेन फोकस कोडाचेर ना मॅम. It is there to highlight how this content should be taught, how the stories should be told, how the interactions with students should happen, and how to drive their attention towards the problem statement and not on the code. Because what we have started realizing, right, is what a lot of teachers are doing is they are directly taking a lot of students to the code. We aren't discussing much of the stories. We are not hearing stories from them. This is where the major focus is. We need to talk about more things like this. See how gravity is, like we just discussed, right? What does gravity do? What happens when we throw something from top? We were not jumping to the code right from the day, right from the start. What happens when things fall down? What do we see? We see it speeding up, right? Or you know, when we want to go from point or positives and negatives, you know, it is not about directly going to the code, but really putting that kind of a graph paper or something in front of them and really showing them, see how you know, we always see what positives and negatives mean, right? It's just a different way of saying in real world we say northwest, east west, north south east west, right? So in programming we have positive x minus x, positive y minus y. Those things need to come out more strongly than the code. Code is for them to go and have fun. Code is not what we are teaching them. This is not about coding.
जाल्यार आमी कोड करनासतना ते प्रॉब्लेम हांगा थंय कड्डान जाता पणूच जाता इल्ल्या भशेन करचें पडटलें म्हणल्यार हांगा थंय सांगपाचें आनी सोडून दिवपाचें म्हणल्यार फायनली जेन्ना साई सर इज देयर आय डोंट नो इज देयर साई सरान जेन्ना व्हिडिओ सांगिल्ले तेन्ना सर कितें म्हणटालो की एटलिस्ट टिचरा कडल्यान ते पावना जाल्यार PMU कडल्यान तरी ते व्हिडिओ कडल्यान पावले जाल्यार एटलिस्ट भुरगीं तरी शिकतलीं म्हळ्यार आमी जर फक्त प्रॉब्लमूच तांकां एक्सप्लेन केलो आनी सोडून दिलें जाल्यार परत तांकां कोड कळपा प्रश्नूच येतलो न्ही आनी कितें आतां स्कुलान शिकयताच म्हणल्या पासून चडशी कोड एक्सप्लेन केल्या भुरग्यांक कळच ना मातशें तरी दाखोवचोच पडटा आतां ऑनलायनच चल्ला सद्या पूण एटलिस्ट तांकां एक्सप्लेन तरी करचो पडटा कोड कितें म्हणटा तो नाल्यार कळना सर तांकां कांय फक्त
So ताजेरूय एक solution आसा ma'am. If you remember how we had done it for the master trainers teachers, we had a separate programming course of around 19 sessions.
हय पूण
Right?
सर पूण आमकां आतां पळय जे व्हिडिओ करपा दिल्या ताजे 32 कितें पळय लेसन प्लॅन्स आसा तांचेर कर म्हूण सांगल्यात म्हणजे तांचेर करतलो जाल्यार ताजेरूच उलोवचें पडना सर आमी त्याच कोडाचेर.
No. Again, ma'am, the focus is not the code. The focus is to make the person curious about the world around him. ताका ती मजा येवंक जाय, ताका ती दिसूंक जाय, ओ आयज आमी कितें तरी करुया. नाल्यार तो भुरगो कितें करता, ओ आपल्याक स्क्रॅच कळ्ळें म्हणटा तो, आपल्याक कांय हें ना. ताका ती मजा देवंक जाय. अरे चल मरे आमी ग्रीटिंग कार्ड करपाक शकता मरे. चल मरे आमी एक गेम तयार करपाक शकता. अरे त्यो 10 शेपी आसा तातूंत तुका ट्रायंगल दिसता रे. It has to be around that. It is not that easy, ma'am. It is not a 5-minute thing. It has to, the whole course, whole lesson plan is more structured around that. That is why you see, right? The whole code is just pretty minimal. It's just for them to see, you know what, this. But in any programming environment, right, the whole coding is very minimal. Because we do not talk about these stories, right? We do not talk about motion. We have then these questions like, why is it, why are we saying the gravity force plus a negative value and not gravity force minus positive value? That is because we are focusing too much on the code. We are not focusing on the concept. The worry is because we have started so fast, right? We have not done enough of hand holding till now. It is possibility that if there is no common recording of these videos, a lot of wrong message will go away. So we can obviously make a separate course around Scratch, around recursions, around maybe drawing some simple shapes of triangles and everything. But that has to be separate. Let's focus on that as more like a coding support. But
आतां सर आमकां पळय जें काम व्हिडिओ करपाचें दिलां तें आमकां कितें सांगलां लेसन प्लॅन 1, 2 लेसन प्लॅन कितली 18, 19, 20 कितें आसा तांचे प्रत्येक लेसन प्लॅनाचेर एक हाजेर एक कन्सेप्ट आसा ताजेर एक व्हिडिओ जाय म्हणल्यार तो लेसन प्लॅन विदावट टिचर्स हेल्प तो भुरग्यांनी पळयलो जाल्यार भुरग्यांक कळूंक जाय जशें युट्यूबाचेर आमी कितें शिकतात सगळें दाखयिल्लें आसता त्या भशेन तो कळूंक जाय अशें आमकां ऑलरेडी सांगलां म्हणल्यार मेगा सोनल तांणी डिस्कस करता आसतना आमकां तोच मेसेज पावयला म्हणजे आमी आतां तो कोड पळय जो कितें आसा तोच एक्सप्लेन करचो पडलो ना नाल्यार आनी कितें करतलीं सर आनी एक्स्ट्रा कितें करतलीं
आमी कितें करुया जाणा मॅम we'll have a separate session with only the video plan committee, Sai sir, Mega ma'am, and them, and then we'll address this properly.
Yeah, sir.
Right? So that everybody comes on the same page, right?
आमी डिटीन येवपाची आसतली चड करून ट्यूसडे.
Okay, मागीर दमदारे Tuesday करुया. So I might need to attend it remotely, but let us do it on Tuesday then. तशें करुया. और ताज्या पयलीं जाता जाल्यार पळयता हांव. We'll discuss together. एक separate group करुया and we'll discuss over there.
Okay, sir.
Right? So मागीर ते clear जातलें ma'am. Right? But again, like, you know, what we are really trying to do, the whole reason why preparing this content, right, is to get the messaging right. So if the messaging right, it will take some time. Till that time, this is our means of doing it. Because if the messages go wrong, right, it should not so happen that some child is forced not to use forever. I mean, obviously he'll lose marks in competitions and other things if we try to do this. But he should not stop coding. He should start. He should first enjoy it. मजा येवंक जाय ताका करपाक, ताका कॉन्फिडन्स येवंक जाय आपल्याकडे जमता म्हणून. You need to find it easy first. And it's more like a goal. It's not like a target. That is what we are saying, right? That's why there are no exams. That's why we are saying do not conduct exams. Right? So it's more like goals. Some childs will get it early. Some kids will get it a little longer. It will take a little longer time. That is fine. But we just need to keep asserting it. And as I said, right, you asked me to code, like probably this gravity that I showed today is completely different from what is there. You ask it to me next week, I'll do it in an even different way. The worry is the moment we show a code, right? The focus goes on the code. Now it becomes, why this code? Why not that other code? The whole topic of this entire curriculum is exactly this. Why this code and why not other code? Every code that works is valid. Focus is not on the code, but they should really come. It's actually a mistake to really say when you are adding forces, right? To actually say this is the number, we are adding it. We need to make it clear that we are adding the forces, and those forces could be positive and negative. Not like the forces are always positive and we are deciding that should I add it or should I subtract it. So it's that way. So the concepts, these are the concepts. When we are talking about gravity and jump, it's basically that there is one positive force, there is one negative force, and we are always adding the forces, right? And eventually they find it. The moment they learn it, building games and everything becomes much more simpler because it's about physics now. Good enough, ma'am?
Yes, sir.
All right,
Yes, sir.
teachers.
Yes, sir.
Yes.
It's sort of almost time up.
Thank you, sir.
What we'll do is we'll share this code, but this is good. Like, if all of you really felt like coming up and asking these questions and coming together here. If you have any more questions, right? Maybe after this, maybe after watching the video, maybe after trying few things. If you have any questions, do let us know and we'll have one more session.
So meanwhile, they can write their queries in that shared document. So you can address it later on.
Definitely. Saisa, are you there?
Yeah, I'm there. Yeah. Any more doubt, teachers? Or I think it's already almost 2 hours. Yeah, I just hope teachers have been able to clarify their doubts. And as the Pallavi teacher has said, the process can continue. Teachers can add their doubts on that Google Doc that has been shared, and it can be answered as and when the questions come. So I would like to thank Anay sir for spending so valuable time addressing the concerns. I'd like to also thank all the master trainers and the teachers for joining this meet. Thanks to you. And let's meet again if we have difficulties. See you all.
Thank you. Bye,
Yeah,
everyone.
my teacher has shared some instructions also. Let's follow these instructions.
Yeah, I've just made a feedback form, sir, which will
Okay.
be active for 15 minutes. It's for attendance as well as the feedback. So whoever has attended can fill in this form and give your feedback to us.
Yeah. Teachers, do please fill this form. Yeah.
Bye, everyone.
Yeah. Bye, sir.